A pleasant day, class. I am your teacher, Juliana Kathina Svensson from Bsed-Eng English Block A1. And today we'll be tackling about the nano world. Are you familiar with the word nano? Well, in this lesson, we hope to get to know the word nano more. So catch up with us, listen thoroughly to this lesson, and we hope that you get to know better about the word nano. So let's begin with teacher Gia for the introduction.
The nanometer is a unit of length in the metric system equal to billionth of meter. The name combines the C prefix nano with the parent unit meter. So, the nanometer, a unit of length in metric system equal to 1 billion of meter. It is a very small of a unit measurement often to describe the size of atoms, molecules, and nanoparticles. Next is technology, machinery, and equipment developed from the applications of scientific knowledge, the branch of knowledge dealing with engineering or applied sciences. Here in technology, machinery, equipment, processes developed from applications of scientific knowledge. It involves using scientific principles to create particle solutions, products, and systems. Technology is a broad field that encompasses engineering, applied sciences, and other disciplines. So, in short, nanometer is a unit of measurement, while technology refers to the practical application of scientific knowledge to create useful things. Next is, what is nanoscience? Refers to the study, manipulation, and engineering of matter, particles, and structures on the nanometer scale. Important materials such as electrical, optical, thermal, and mechanical properties are determined by the way molecules and atoms assemble on a nanoscale to larger structures. So, nanoscience is materials and course the study of manipulation and engineering of matter, particles, and structures on the nanometer. At this scale, the properties of materials, electrical, optical, thermal, and mechanical properties are determined by molecules, atoms, assembled into larger structures. So it allows us to understand and control property of materials at the nanoscale, which is crucial for developing new materials and technologies with unique properties by manipulating matter at the atomic and molecular level. Scientists and engineers can create materials with tailored properties, leading to breakthroughs in various fields. Next is, what is nanotechnology? So this is the origin of nanotechnology. In 1959, American psychiatrist Richard Feynman gave a famous talk called "There's Plenty of Room at the Bottom," which is considered the first major idea of nanotechnology. He explained that if we could control and work with things at extremely tiny scale, we could discover new and unusual behaviors of materials. Feynman also challenged scientists to create a very tiny computer and to make writing so small that the Encyclopedia Britannica could fit in the head of a pen. So the term nanotechnology, it was first used by the Japanese scientist Norio Taniguchi in 1912, 1999. In 1974, paper on production technology to create subjects, and that's the beginning of the nanotechnology.
Good day everyone, I am Sts G3 and my topic is all about how small is a nanoscale. The nanoscale refers to a size between 1 and 100 nanometers. To understand how small that is, 1 nanometer is equal to 1 billionth of a meter. Example, a human hair is about 80,000 to 100,000 nanometers wide. A DNA strand is about 2 nanometer wide. A virus is roughly 2 to 300 nanometer size. Example anak guys, kanang buhok. Gamay naman kanang buhok. Mas gamay pa ng nanometer ano. Yes. A water molecule is less than 1 nanometer across. That's all guys, and have a good day.
Good day everyone, welcome to our class. Once again, I am teacher Juliana, and today we will be tackling about how to view nanomaterials. Now Renz, or your teacher Renz, has discussed how small a nanomaterial is, so it cannot be seen through light or through your bare eyes. So there are ways or tools to use to view nanomaterials. So nanomaterials are again too small for ordinary light microscopes. So scientists use advanced microscopes to observe structures at the nanoscale. And the early use of electrons and field microscopes is in the year 1930s. Now we have researched 3 materials or tools to use to view nanomaterials. And number 1 is the electron microscope. Yes, as you can see there on the screen, you have there an example or the picture of an electron microscope. So Ernst Röska and Max Knoll invented the first electron microscope in 1930s. It uses a beam of electrons to produce a clear and highly magnified image, allowing it to enlarge objects up to 1 million times compared to a light microscope that is 1,500 times. So it is a microscope that uses electrons instead of light to make very tiny objects look big and clear. So the difference between an electron microscope from the basic microscope is that it uses electrodes instead of light because nanoscales are very small that it cannot be seen in the usage of microscope. So who invented it? Again, it is invented by Ernst Röska and Max Knoll in the year 1930s. So how powerful is this microscope or the electron microscope? For example, a light microscope can zoom in up to 1,500 times, while an electron microscope can zoom up to 1 million times. This shows how nanomaterials, viruses, and atoms. So see how vast or how powerful a electron microscope is, because from 1,500 mo na siya normal nga pag-zoom sa microscope to 1 million times nga pag-zoom. So makita yun yung nanoscope, even the viruses and atoms. So we can really say that this invention in 1930 is really a boom in the scientific economy kay. For example, kanyan nanomaterials, makita na nimo through this invention. Now there are 2 types of electron microscopes. One is the SME or the scanning electron microscope, and the TEM or the transmission electron microscope. When we say SME, again the scanning electron microscope, it looks at the surface of an object, shows a 3D-like picture of outside. For example, seeing the bumps and shapes of a nanoparticle. So when using an SEM or scanning electron microscope, you can see the surface of the object and shows 3D-like picture of the outside. So makita nimo ang bumps and even the shape of the nanoparticle. Second type is the TEM or the transmission electron microscope. It looks through a very thin sample, shows a detailed picture of the inside. For example, is seeing layers of structures inside a nanomaterials. Again, it shows a very detailed picture of the inside. So the difference between SEM and TEM is that SEM, you can see the surface level of the object or the nanoparticle. The TEM, on the other hand, shows the detailed pictures from the inside of the nanoparticle. So that is the first microscope or the first tool to see nanomaterials. It is the electron microscope. Now let's go to the second tool, which is the atomic force microscope or the AFM. Again, you can see on the PPT an example picture of this tool. It was developed in 1986 by Gerd Bing, Calvin Quaid, and Christopher Gerber. It uses a tiny mechanical probe to collect information from surface of material. So it is a tool used to see and feel the surface of very tiny materials, including nanomaterials. Again, it is developed in 1986 and it uses a very tiny and sharp tip. So nakita ninyo diha sa picture that it has tip sa ubos. Like it is a finger light to touch and scan the surface of a material. As the tip moves around the surface, it feels the bumps, holes, and shapes. So, ang katong tiny light, the finger light nga kuan, tip mo to siya ang mo touch and mo scan sa surface to know or to feel the bumps, the holes, and the shapes. So, if i-compare nimo siya sa electron microscope o ang atomic or ang AFM, ang differ niya kay ang timeline. Okay, if you could remember, discuss na to nga sa electron microscope. It was discovered in 1930s. So this is the first invention of tools to view nanomaterials. And then comes the AFM, which is invented in 1986. Same sort of usage, and you can feel the surface, the bumps, but this is a more, we could say advanced type of material. Okay. And now, a computer, and then after feeling the surface, gamit ato ang finger-like nga tip, a computer then turns this information into a picture of the surface. So, naana ka visualization of what the surface is. So, let us put this into an analogy, or let us simplify this analogy. So, imagine yourself. So, let us close our eyes and imagine ourselves na nag-run itong fingers through an object. Even without seeing it, diba, you can still feel the surface if it's bumpy, if it's rough, if it's smooth, or it has bumps. That is the analogy, or that is how we simplify the usage of AFM. So, you can feel the object. Another information or further information about AFM is that it shows the shape of the surface, tiny bumps, textures, very small particles, and even surface roughness. Yes. And another one is the scanning tunnel microscope. This microscope lets scientists see and control very tiny particles, including atom molecules. Yes, it was important that these inventors, Gerd Bing and Heinrich Wöhrer, invented in 1986. So same with the AFM, you can feel, you can touch it, but ang kalahian nila kay in sa kuan man gud AFM, ma-feel nimo siya through touching it. But in scanning tunnel microscope, ma-feel nimo siya through the dancing or the movement of particle of that specific nanomaterial or nanoparticle. So the usage, same po na siya actually sa AFM o sa previous or katong sa electron microscope nga it has finger-like na tip to feel the surface, but ang kalahian aning scanning tunnel microscope is ma-feel nimo siya not through by touching, but through feeling or through feeling or knowing the movement or of the nanoparticles. So that concludes on how to view nanomaterials. Again, let us recap. We have first the electron microscope that was invented in 1930s. It is 1 million times more vast than usual microscopes. It can zoom in to 1 million times, imagine that. Second is the atomic force microscope or the AFM, invented in 1986. Lastly is a scanning tunnel microscope invented in 1986 again, that you can feel the nanoparticles through knowing the movement of the particles. So that concludes my part for this topic. Once again, this is teacher Juliana, but stay put as we will discuss about nano manufacturing that will be discussed by your teacher Hennessy Yu.